Wormholes, cosmic shortcuts that could connect distant points in space and time. You've probably seen them in sci-fi movies, but are they real? Here's what we know so far. They're predicted by Einstein's equations. Albert Einstein developed his theory of general relativity in the early 20th century. It revolutionized our understanding of gravity, space, and time. According to Einstein, gravity is not a force, but a curvature in spacetime caused by mass and energy. This means that massive objects like planets and stars warp the fabric of spacetime around them, creating what we experience as gravity. But this also means that spacetime can be warped in other ways, like into a tunnel connecting to distant points. These tunnels are called wormholes, but don't get too excited yet. We haven't found any wormholes yet. And even if we did, it's not like we could use them for space travel. Why not? Keep watching to find out. First, let's talk about the good things about wormholes. They're theoretically possible. As I said before, Einstein's equations predict that wormholes should exist. These equations are known as the field equations of general relativity. They are extremely complex and have been tested countless times. They describe how spacetime is affected by matter and energy. And one of the solutions to these equations is the wormhole. It's like a mathematical curiosity, an oddity that pops up in the equations but doesn't seem to have any physical meaning. However, mathematicians have shown that under certain conditions, wormholes can be solutions to Einstein's equations. These conditions are very extreme and require exotic matter with negative mass energy density. But that's not beyond the realm of possibility. In fact, some physicists believe that such matter exists. Wormholes could connect distant points in space and time. The idea is that a wormhole is a tunnel through spacetime, a shortcut between two distant points. If you were to travel through a wormhole, you would emerge out the other end much farther away than where you started. In theory, a wormhole could connect 2 points that are light years apart or even to different universes. This means that a wormhole could allow for faster than light travel. This is because the distance between the 2 points would be reduced to zero. It's like taking a piece of paper and folding it in half. The 2 ends of the paper are now connected, and you can travel from one end to the other instantly. Of course, this is just a crude analogy, and the actual geometry of a wormhole is more complex, but the idea is the same. A wormhole is a way of getting from one point to another without traveling through all the space in between. Now, let's talk about the bad news. Wormholes are unstable. If they do exist, they are likely extremely unstable and could collapse instantly. This means that if you were to try to travel through a wormhole, you would probably be met with a big explosion. Not exactly a pleasant way to go. The reason why wormholes are so unstable is because of the exotic matter that holds them open. As I mentioned before, wormholes require this type of matter to keep them from collapsing. But this matter is also the thing that makes them unstable. It's like trying to keep 2 pieces of paper stuck together with a thin piece of thread. If the thread breaks, the pieces of paper will fall apart. The same is true for wormholes. If the exotic matter that holds them open decays or disappears, the wormhole will collapse. And when it does, everything inside the wormhole will be crushed together at the point where it collapses. This means that anything that enters a wormhole risks being destroyed. So, if you were to try to use a wormhole for space travel, you would need to make sure that it's stable. But even then, there's no guarantee that it would stay that way for long. Not only are wormholes potentially dangerous, but they might also be closed off to us. Even if we could create a stable wormhole, it might not be accessible to us. This is because the mouths of wormholes are often referred to as event horizons. This is similar to the event horizon of a black hole, which is the boundary around a black hole beyond which nothing can escape. The same is true for a wormhole. Once something crosses the event horizon, it cannot come back out. This means that if we were to send a probe through a wormhole to explore the other side, we would never see it return. This is because the information about what happened to the probe would never be able to cross the event horizon and reach us. This is known as the one-way nature of a wormhole. It's like pouring water into a funnel. The water can go in, but it can't come back out. This means that a wormhole is essentially a time-like version of a black hole. And just like a black hole, it's possible that the interior of a wormhole could be completely hidden from us. This is because the light that enters a wormhole never comes out. This means that we would never be able to see what's inside a wormhole. We would only be able to see the bright light coming from the event horizon. This is known as the black hole information loss paradox, and it is one of the biggest unsolved mysteries in physics today. Some physicists believe that the information about what goes into a black hole is lost forever. Others believe that it is stored on the surface of the black hole and can be retrieved if we had the technology. It's possible that the same thing happens with wormholes. The information about what goes in is stored on the surface of the wormhole and can be retrieved if we had the technology. However, we currently don't have the technology to do this. So, for all we know, the interiors of wormholes could be completely hidden from us. So, even if wormholes exist, it's possible that they are closed off to us. We can't see inside them, and we can't get out once we enter them. This is why it's unlikely that we'll ever be able to use wormholes for space travel. The idea of wormholes has captured the imagination of scientists and science fiction fans alike. The idea of being able to travel faster than light and visit distant parts of the universe is incredibly appealing. However, it's important to remember that wormholes are just theoretical objects. There's no evidence that they actually exist. And even if they do exist, it's unlikely that we'll ever be able to use them for space travel. Wormholes are unstable and dangerous, and it's possible that they are hidden from us. Nevertheless, the idea of wormholes is an exciting one, and it continues to capture the imagination of scientists and science fiction fans alike. Who knows? Maybe one day we will discover that wormholes are real and we'll be able to use them to explore the universe. Thank you for watching. We hope that you enjoyed learning about wormholes, cosmic shortcuts that could connect distant points in space and time. While wormholes are still purely theoretical, the idea of being able to travel faster than light and explore the universe is incredibly exciting. Who knows? Maybe one day we will discover that wormholes are real. If you enjoyed this video, be sure to subscribe to our channel for more fun science videos. Thanks for watching.